A previous year board question from the chapter of chemical kinetics. For the reaction 2NO gaseous plus Cl2 gaseous giving 2NoCl, the following data were collected. All measurements were taken at 263 Kelvin. Four experimental sets of experimental data are given. That is the initial concentration of NO, initial concentration of Cl2 and initial rate of disappearance of Cl2. Concentrations given in molars and initial rate of disappearance in molar per minute. Now we are asked to write the expression for rate law, then calculate the value of rate constant and specify its units. What is the initial rate of disappearance of Cl2 in experiment 4? First, it is write the expression for rate law. Let us see how to do that. This is the table with the experimental data. We can say K equal to, or rate equals rate constant K into concentration of NO into raised to X into concentration of Cl2 raised to Y. We do not know the values of X and Y. We need to find them. Now from the given data, we can write for the first experiment, initial rate of disappearance, that is rate of disappearance is 0.60. That is equal to K into concentration of NO, that is 0.15, raised to X into concentration of Cl2, 0.15 raised to Y. That is the first equation. Second equation, 1.20 equal to K into concentration of NO is 0.15 raised to X into concentration of Cl2 is 0.30, 0.30 raised to Y. That is the second equation. Now for the third one, we can write 2.40 equals K into 0.30 raised to X into 0.15 raised to Y. That is the third experiment or third equation. Now from this data we need to calculate X and Y. So dividing equation 1 by equation 2, we can write 0.60 equal to K into 0.15 raised to X into 0.15 raised to Y divided by second equation, 1.20 equal to K into 0.15 raised to X into 0.30 raised to Y. Let us simplify it. 0.60, 1, and here it will be 2. K and K will get cancelled. These terms will get cancelled. This under simplifying will give you 1 by 2. So 1 by 2 equals 1 by 2 the whole raised to Y. So Y is equal to 1. So we have found the value of Y. Now let us see the value of X. So dividing equation 1 by equation 3. Let us write. First equation is 0.60 equal to K into 0.15 raised to X into 0.15 raised to Y divided by the third equation is 2.40 equal to K into 0.30 raised to x into 0.15 raised to y. Here also on simplification we can get 1.1 by 4 equal to, these terms will get cancelled, k and k will get cancelled. This on simplification will give you 1 by 2 equals 1 by 2 the whole raised to x. So 1 by 4 equal to 1 by 2 the whole raised to x. X equals 2. Now we know x and y. Let us substitute for their values in the rate equation. So rate equals K into concentration of NO raised to x is 2. 2 into concentration of Cl2 raised to 1. We need to write that. So that is the expression for rate law. Now calculate the value of rate constant and specify its units. We need to calculate rate constant. So we know rate equals K into concentration of NO raised to 2 and concentration of Cl2. This is the rate equation. Now if we take the first equation or the first experiment, we can see 0.60 is the initial rate of disappearance of Cl2. So we can take that as 0.60 equals K into concentration of NO. Is both NO and Cl2 are 0.15 each. So we can write 0.15 raised to 2 into 0.15. On doing this, we can see K equals 0.60 by 0.15 the whole cube. When we do the calculation, we will get the quantity as 177.77. Now we need to find the unit of it. So the rate of disappearance of Cl2 is given in molar per minute. So molar per minute equals K into, this is given in molar units. So molar raised to 2, 0.15 raised to 2 is molar raised to 2, and the rate of disappearance again is in molar. We will get it like this. So we can say K equals m by m, this is molar per minute, into molar cube, m raised to 2 into m. Now that will give us, we can cancel this, and this one goes up will become m raised to minus 2, that is molar raised to minus 2, minute raised to minus 1. So that will be the unit of K. Okay. Now, what is the initial rate of disappearance of Cl2 in experiment 4? We have got the rate constant K as 177.77. We are asked to find the initial rate of disappearance of Cl2. Now, we can do that from the equation rate equals K into concentration of NO and Cl2 are 0.25 each in experiment 4. So 0.25 raised to 2 into 0.25. Rate is rate of disappearance is what we need to find. So K is given as, or we got it as 1.77 into 77 into 0.25 the whole cube. Now on doing it, we will get the answer 2.773 molar per minute.